How is ping lossless given that it has a compression parameter? Ping files are said to use lossless compression. However, whenever I am in an image editor, such as GIMP, and try to save an image as a ping file, it asks for the compression parameter, which ranges between 0 and 9. If it has a compression parameter that affects the visual precision of the compressed image, how does it make ping lossless? Do I get lossless behavior only when I set the compression parameter to 9?
Ping is lossless. GIMP is most likely just not using the best word in this case. Think of it as quality of compression, or in other words, level of compression. With lower compression, you get a bigger file, but it takes less time to produce, whereas with higher compression, you get a smaller file that takes longer to produce. Typically you get diminishing returns, i.e. not as much decrease in size compared to the increase in time it takes when going up to the highest compression levels, but it's up to you.
Ping is compressed, but lossless. The compression level is a trade-off between file size and encoding/decoding speed. To overly generalize, even non-image formats, such as FLAC, have similar concepts. Different compression levels, same decoded output. Although the file sizes are different, due to the different compression levels, the actual decoded output will be identical. You can compare the MD5 hashes of the decoded outputs with MPEG using the MD5 muxer. This is best shown with some examples. Create ping files. By default, MPEG will use compression_level 100 for ping output. Compare file size. Decode the ping files and show MD5 hashes. Since both hashes are the same, you can be assured that the decoded outputs, the uncompressed, raw video, are exactly the same.
Ping compression happens in two stages. Pre-compression rearranges the image data so that it will be more compressible by a general-purpose compression algorithm. The actual compression is done by deflate, which searches for and eliminates duplicate byte sequences by replacing them with short tokens. Since step 2 is a very time/resource intensive task, the underlying zlib library, encapsulation of raw deflate, takes a compression parameter ranging from 1 equals fastest compression, 9 equals best compression, 0 equals no compression. That's where the 0 to 9 range comes from, and GIMP simply passes that parameter down to zlib. Observe that at level 0 your ping will actually be slightly larger than the equivalent bitmap. However, level 9 is only the best that zlib will attempt, and is still very much a compromise solution. To really get a feel for this, if you're willing to spend 1000x more processing power on an exhaustive search, you can gain 3 to 8% higher data density using Zopfli instead of zlib. The compression is still lossless, it's just a more optimal deflate representation of the data. This approaches the limits of a zlib-compatible libraries, and therefore is the true best compression that it's possible to achieve using ping.
A primary motivation for the PNG format was to create a replacement for GIF that was not only free but also an improvement over it in essentially all respects. As a result, PNG compression is completely lossless, that is, the original image data can be reconstructed exactly, bit for bit, just as in GIF and most forms of TIFF. PNG uses a two-stage compression process. Pre-compression, filtering, prediction. Compression, deflate, see Wikipedia. The pre-compression step is called filtering, which is a method of reversibly transforming the image data so that the main compression engine can operate more efficiently. As a simple example, consider a sequence of bytes increasing uniformly from 1 to 255. Since there is no repetition in the sequence, it compresses either very poorly or not at all. But a trivial modification of the sequence, namely, leaving the first byte alone but replacing each subsequent byte by the difference between it and its predecessor, transforms the sequence into an extremely compressible set. The above transformation is lossless, since no bytes were omitted, and is entirely reversible. The compressed size of this series will be much reduced, but the original series can still be perfectly reconstituted. Actual image data is rarely that perfect, but filtering does improve compression in grayscale and true-color images, and it can help on some palette images as well. PNG supports 5 types of filters, and an encoder may choose to use a different filter for each row of pixels in the image. The algorithm works on bytes, but for large pixels, for example, 24-bit RGB or 64-bit RGBA, only corresponding bytes are compared, meaning the red components of the pixel colors are handled separately from the green and blue pixel components. To choose the best filter for each row, an encoder would need to test all possible combinations. This is clearly impossible, as even a 20-row image would require testing over 95 trillion combinations, where testing would involve filtering and compressing the entire image. Compression levels are normally defined as numbers between 0, none, and 9, best. These refer to trade-offs between speed and size, and relate to how many combinations of row filters are to be tried. There are no standards as regarding these compression levels. So every image editor may have its own algorithms as to how many filters to try when optimizing the image size. Compression level 0 means that filters are not used at all, which is fast but wasteful. Higher levels mean that more and more combinations are tried on image rows and only the best ones are retained. I would guess that the simplest approach to the best compression is to incrementally compress each row with each filter, save the smallest result, and repeat for the next row. This amounts to filtering and compressing the entire image 5 times, which may be a reasonable trade-off for an image that will be transmitted and decoded many times. Lower compression values will do less, at the discretion of the tool's developer. In addition to filters, the compression level might also affect the SLIB compression level, which is a number between 0, no deflate, and 9, maximum deflate. How the specified 0 to 9 levels affect the usage of filters, which are the main optimization feature of PNG, is still dependent on the tool's developer. The conclusion is that PNG has a compression parameter that can reduce the file size very significantly, all without the loss of even a single pixel. Sources: Wikipedia Portable Network Graphics, LibPing Documentation Chapter 9, Compression and Filtering.